we might be able to watch it again. So I asked ChatGPT for a nice title, and "Are You Ready?" was really cool. So I liked it. It's about integrating large language models in R in various ways. To give you a little bit of a background, I also work as a consultant for the Austrian Ministry of Education regarding how to best integrate such large language models in schooling. And I use them therefore a lot for IT projects because we are an IT focused vocational technical high school, HTL, which means that these kids learn 20 hours per week programming and IT, and they are super good in their fourth or fifth year, and therefore they can do projects for the Ministry of Education, the Ministry of Defense, or whoever comes to us and wants something done. And therefore I dove into this years ago already and collected a few insights. To be honest, I didn't do it in R for the longest time because Python was a much more efficient thing and much more widely used out there. But I was actually curious to get to know what's available in R and play around with a few things, and therefore I want to share a few insights. And in order to not make this too scary for you, I did this in the pedagogical way. So our brain should connect different things apart from the application, maybe get a little bit of the background as well, and to introduce you with a few of the concepts behind LLMs, because we will require some of these concepts and vocabulary when we then apply them and use the API connections for using these LLMs directly through R. So the bar up there is in a super bad place, but this should be better. AI, machine learning, deep learning, large language models. All these terms are frequently used. All these terms are the buzzwords nowadays. So if you want to get research funding, use at least one of them. Otherwise, it won't be good for your money. So what are they? So no one's absolutely sure what artificial intelligence actually is. So there are various definitions and no clear one, because we can't even agree what human intelligence is, and therefore doing the transfer to the artificial thing is even worse and more complicated. But at least we can agree on what we think that machine learning is, which is learning concepts of pattern recognition, of classification with machines, which are typically decision-making processes made by the human brain. We also know neural networks. They've been around for decades. They've been cool and not so cool for decades. And they became really fancy a few years ago through the arrival of these large language models. Before that, they were already declared dead. And then ChatGPT came out, and all of a sudden, it was super cool to do all this AI stuff. And therefore, we will look a little bit about what these things can do and what they can't do. You may think I'm a little bit crazy if I talk with you about classification, but please bear with me. There's a reason why we're talking about classification, because this is something we will need again for these large language models. This is some nonlinear classifier. We're not specifying exactly what a machine learning model does, But in the end, we have these different classes, and for each of them, we get a probability of which class would be fitting for a certain task, which is the predictive task which we expect our model to do. The other part is text models. And behind any kind of text models is transforming words into numbers, vectors with a lot of numbers, because none of these large language models actually works with words, but they all work with vector space embeddings, transforming any kind of words and texts into several thousand dimensional vectors. These vectors are supposed to preserve certain structures existing in the natural language. One of these structures is the change from the male to the female form. This should also always happen in a reproducible way, let's say. Also, they should be able to preserve tenses, grammatical structures of a language, and they should preserve certain context meanings, such as having a country and the corresponding capital of that country, and therefore having the same distance, the same vector to go from Italy to Rome as from Germany to Berlin. Why is this relevant for our LLMs at work? They are deep learning. Because as soon as you see a neural network and it has several layers, this thing is called deep learning. And therefore, all these models here are deep learning models. The input is mainly text, so everything we look at in R is text. However, they're a lot cooler by now. They can do image input, verbal input, even data structure input, and provide an output. This is just a neural network classifier, but an LLM is mainly about predicting the next word with the highest probability based on the context, the prompt, and the previous words generated in the text. Therefore, large language model basically is also a classifier, which is focused solely on predicting the next most plausible word. And to give you an idea, when we talk about classes here, the English language has between 200,000 and 1 million words. The German one has about 5 million words. The average native speaker has a vocabulary of about 20,000 words. So this is kind of the dimensions we're talking about when we talk about classification in the sense of predicting the next word as a kind of class in a certain context. Good. Behind all this are transformers. If you want to have a really bad night, you can look at the thing on the right side. For the simpler thing, and this will be important for us in the next part when we look into the R applications, is how this attention mechanism work, because the groundbreaking paper for this was attention is all you need. And here is a kind of very simple explanation of what attention is about. It's about focusing which words have very highly plausible connections with which other words. The word it in this context is something which we want to refer to another noun in the context. Therefore, animal would be the thing, animal doesn't exist without its article, therefore it's the animal which has the highest plausibility here. And then it has high attention also with other words. It and the T, surprisingly, has the second highest attention focused on, even though the T in itself is a token without a reasonable meaning. What we see here is the tokenization happening, because it's not just about splitting the thing up into words, it's also about splitting up forms of grammar. And you see it most clearly with the didn't, because for us as humans, didn't is a single word. It wouldn't even occur to us to use the apostrophe as a separate token and the T as a separate part. But from the perspective of the large language model, any kind of symbol used in a sentence, whether it's a colon, a semicolon, point, ending some sentences, structuring sentences, or such apostrophes, they are tokens, and they're handled as separate parts, just like word parts and parts which correspond to the grammar. The English grammar doesn't have so many endings which refer to grammar parts, only the S in the third person. Whereas in German, you would see a lot more splitting up of the token parts which refer to the word stem and the other token parts which refer to the ending, the grammatical structure of it.
And that's with the higher at the end.
Yeah, and with higher, because higher already is a word and you can use it as a verb in English, and the D then refers to a certain form of this word. So yeah. But English is a lot nicer than German, so they don't have so many of these, but German has a lot. So it's a lot more complicated to learn. The reason why I focus on this is that the number of tokens which we send to the models, but also which we receive as an answer, is something which we can regulate in the R packages. And therefore, it's relevant to be aware that not every word is a token, but there are a lot more tokens than words. Especially since these grammatical structure things and these sentence parts are also tokens in themselves. Good. We will also talk about a few of the tasks for large language models. Most of them you know anyways. So there's just a brief overview of what kind of data is available, but we will focus on the tasks, and we will focus on more or less the first two tasks. Because information extraction is something very simple. We all know that just giving any of these large language models a text and saying, write me a summary of this, is one of the most basic tasks to do. However, if we send this via an API key to whichever server is hosting our large language model, it will use up a lot of these tokens because the whole text has to be sent there. And therefore, it's super inefficient and it's expensive to use. That's why I don't demonstrate this part, but I demonstrate the other two. Answering questions, helping through coding, and also doing a sentiment analysis, kind of using this large language model to train it to do a very specific type of classification, which is the classification of sentences with respect to their sentiment. So in case you've ever tried out telling these large language models, write me an email and write it in a more humorous way, or write it in a very sad manner, because I really want to beg for mercy from my professor to get this positive grade. You will notice that it changes a lot of the adjectives, it changes certain nouns, and it changes also the structure of the sentences. How? How do these things know, or have they ever learned what is a sad or a humorous sentence? And the answer is, oh, they've learned it super well because they got a lot of labeled data for that stuff. You provided labeled data for all these large language models, and you did so for years, for decades possibly, in case you've ever used some kind of social media network. If you ever used WhatsApp, if you ever used Facebook, you have written something there, commented something there, then your data is in the training data for these models. And they have been labeled to a certain degree. If you ever wrote on Google some kind of critique for a restaurant or a hotel, it's also in there, or at booking.com or wherever. Because they got these data, they labeled these data, and there they have a very clear structure, short sentences and clearly pronounced words. Because you either write these critiques because you really love the place, or you really hated the place. Hardly anyone writes it like, yeah, it was okay, it wasn't bad, it wasn't good. Usually it's enthusiastic or terrible. And therefore, this is the perfect kind of data for training sentiment, learning which adjectives will trigger certain emotions or are connected with certain emotions. And once you have these labeled data, it's of course simple to go the other way around, to give it sentences and ask for the labeling in return. And that's what we will look at as a classification task, because that is the classical type of classification task to use with R. Yeah. Good, so much for that and a little bit of storytelling. The dark secrets behind all these things, what we don't know anymore. So back when there was ChatGPT 3, that was before it became famous. Back then they hadn't sold their soul yet to Microsoft for several $billion, and therefore they still worked for an open AI world, as the company was named originally, and thus they also told to a certain degree at least what kind of data was behind this as a training data. Books 1 and 2 is very unspecific, but this includes like huge projects like Project Gutenberg, where you have a lot of literature books available. Wikipedia is kind of clear what kind of data this is. Then there are lots of open web texts, which include news media and such stuff. And then there's the common web crawl, which is kind of something of everything, and no one's so absolutely sure what exactly it is and what the quality of that stuff is. So that was back in GPT-3 times. By now, they have several lawsuits being sued for whatever they took without asking in advance and without caring about copyright. And therefore, they don't even show anything like this anymore. It's just a mystery in the black box. We don't talk about it anymore. This is the less expensive solution. So we will be able to use several models, and I will present to you several options of how to choose between different models. Of course, GPT, OpenAI has become almost a synonym for large language model in itself, just like Google has almost become a synonym for web searching. But there are others around, and it's not yet as well established. So we will look at options of locally running such systems. And that's why I want to introduce you to Ollama if you're not yet familiar with this. Because Ollama is a method of hosting your own LLMs on your own machine, running them locally, therefore. It's an open source project. And since you're running everything locally, you don't need API keys. You don't even need an internet connection. And especially, you don't have to send your data to the cloud. This might be relevant. If you work for a bank, you shouldn't send your data to the cloud. Your employer will not be happy about that. However, hosting something locally preserves everything because nothing leaves your local machine and your local memory. The problem with that is, of course, the models you can use are limited, and also your system resources are limited. We don't have the super cool, great, and fast AI servers. So I only use it for one or two of the model examples, which I will show you them. But I wanted to present to you the option of doing this. In particular, if you work in the research field and you have server available, then this might be an option because it's super easy to run these things locally. Okay, that was the background. Shouldn't have been too bad and too long. Yeah, I was talking a bit longer than expected. That always happens to me. My students are not so happy, but it's okay. And then I dove into what kind of models are out there. And I also tried out the GitHub Copilot for our studio. So if you're already registered on GitHub, you can easily activate the Copilot there for free. Yeah, so this is Ollama. And regarding this Copilot, you have here the Your Copilot thing on GitHub and can therefore activate Copilot for free usage in your system. And once you have done that, you basically need to set it among the things in your RStudio where you can enable this GitHub Copilot. And for once, you have to log in there or sign in GitHub. Otherwise, you will not have a connection. Once you have it, it starts auto-completion if you allow it. So I did it here that it does the code suggestions automatically. Otherwise, you can also trigger it manually. Just using Control and \, which is the predefined version of RStudio. Since using it, I got sometimes very annoyed with it, but in other situations, it's actually very helpful for constructing certain parts, even constructing texts which comment on what you're currently writing and coding, which is really nice. Yeah, so that is the Copilot. And then we look into different R examples. The first one is for the OpenAI library. Okay, this is one which is here. And this one then allows to choose a model which you have available from GPT. The base model, if you don't want to pay for that thing, is GPT 3.5 Turbo. in any case, if you use this, you have to set an API key. And since I'm not a computer science person, this was a challenge for me. So I will briefly show you how to do this and where to do this. In case you're just a dummy like me and grateful for such information. So we're in the part of OpenAI where the actual platform is happening. And so it's platform.openai.com. And here there is the option for setting these API keys. You need to set an API key in order to be able to use all of these are packages which connect directly to the servers, especially which connect directly to these GPT models. So once you read this, you first need to have an API key in order to be able to run it. Otherwise, it simply won't work and tell you that you didn't pay and therefore it won't do anything for you. Therefore, you have to at least activate and deposit some money to create this API key. You can see here from the usage, this was just for running this, I don't know, 100 times today, and it costs 29 cents. So it's not that expensive, especially if you want to play around. This was whenever I used the 4 model. If you just use the 3.5 model, you will not pay anything. You just have to pay a deposit there. So this might be relevant to know how to activate that thing. Good. So that is the first part of this chat. And then there is the message part. And here you can see that there are 2 types of messages sent to the large language model. Usually, when you use the chat interface, you're always in the role of the user. So whatever you write to ChatGPT or any other of these large language models is the stuff which lives here in the content thing. This is your actual request. Usually, you do not see the other type of prompt, which is always happening, which is the so-called system prompt. This is what's happening behind the scenes, let's call it. This is what OpenAI typically sets for all their models. And in this case, you can adapt it. You can add to the system prompt, which exists already, and therefore add something to whatever your user will add as a request. So in this case, I added to the system prompt, you are an R expert, because I wanted it to be able to reasonably answer all my example questions, which would refer to R. And by telling it, you're an R expert, I provide this context, and therefore I hope that the answers which I will receive will be closer connected to something of relevant to the field of the R community and also to programming in R, as opposed to simply hearing about linear regression, because explaining linear regression without the context that I want to do this with respect to R, with respect to computation, with respect to interpretation of output is completely different. Linear regression from the perspective of a chemist or a biologist will receive completely different answers. So if you write in there, you are an expert for molecular biology, you will receive a completely different answer for the same user prompt. So with this system prompt, you really provide a wider context, but you can also narrow it down in a sense that you will receive better answers for whatever you're gonna ask afterwards. Okay, yeah. So that's why I wanted to talk about these things in a little bit more detail. Basically, executing this means it's sent to GPT, it's executed live now, and with this chat object, which I receive back, it tells me which model exactly it has used, which is a little bit different from what I had here. Here it says 0125, which means that is the GPT model from January 2025. Good. Then you find here the message content. And this message content, which is now cut and which I will show you in full, this is the answer we would receive back from the large language model. Okay, so now it's explaining linear regression with the background that it's an expert in R, which doesn't mean that it automatically provides R code. I didn't ask for any code or anything. Okay, but that is kind of the context. This is the OpenAI library. As the name tells you, it only works with ChatGPT models. Then there's the other thing, and this is Elma. And Elma is the library which is now the most flexible of them all. So we'll briefly go there in the packages to give you an overview. So here it has all these named chat functions. And you can already see from the names of these that it has connections with a lot of existing systems. And what is the most valuable for us or the most flexible for us is that it also has this OLAMA connection. Because this means that this is not something where I can only run the thing with an API key, but by using this OLAMA chat, I'm able to run it locally with any of the models which I have previously installed locally. Okay, so this is an advantage. The main problem is it's limited by my system resources. And since I'm now running Zoom in parallel with everything, it will not be super great. That's why I left most of my examples to run in real time now with the OpenAI thing, but we will also run one with OLAMA to see how it works and what we can actually do there. Good. Yeah, so this is the Elma thing. Therefore, you choose the chat based on which model you want or which provider you want. And then within you choose the exact model you want based on your payment and whatever other conditions exist with the different types of providers. Good. In this case, I told him, oh yeah, I have this problem. I have a data set with a column that's named income, and it contains some missing values. They are represented as NA. And I would like to ask him that he should suggest some R code to identify and replace the missing values in this income column with the medium value. Basically, this is run by this chat thing, and then I receive here the outcome for all this. I've run this already several times today. It has been a little bit different every time, so I'm always curious what's happening now. This time I get a dplyr solution, identifying these NAs here, calculating the median of all which are not NA, and then replacing all the missing values with this medium income, which is basically what we would have expected. Yeah.
The variable data description, is it just for us, so we know what's going on, or what the idea of the task is, or is it used sometimes?
It's actually used because it requires this as a context, otherwise it wouldn't be able to refer to it. But it's not obvious where it's used. So, but we have the chat thing. Which is in this case only this very non-informative structure thing. You're absolutely right, because I originally had that they are concatenated, but at the moment they are not. Oh no, yeah. This is just for us, the task description, because I repeat this income thing anyways, and therefore it's a nice to have, but apparently it doesn't need it. And all the information is just repeated in the request itself. So currently it's not using it. Yeah. Good. Oh yeah. The infamous p-value, I didn't actually come up with this. This was the first answer I got, and it was so nice that I kept it for the slide. The question was summarize the concept of p-values in statistical hypothesis testing in one sentence in a humorous and statistically correct way. Now we do it with OLAMA. Previously, just to show you this, I had to install this OLAMA, and then any model you want to use, you can simply receive with a pull request. And in this way, use Llama 3, Mistral, even DeepSeek R if you have a powerful machine, because these models will have different system requirements. And in order to get a good overview of which model might be good for which situation, OLAMA provides you with a model overview where you can also see how large the model in itself is, how many parameters there exist. So even if there are different versions with different numbers of parameters, because these will put the hardest strain on your system. And if you don't have the RAM for running this, you should rather stick with the smaller models, even if the output will not be as good as with a large model, but otherwise it will simply collapse your system, and that's not the purpose. Okay, yeah.
These all still run locally.
They all run locally. So Gamma is the version of Gemini, of Google's Gemini technology. This is really DeepSeek for running it locally. So in this case, you can use the model without having anything deposited on some server out there. So you can play around, you can test it, you can do whatever you want with it, which is really cool. Yeah. And we can do it with R. It's even cooler. Yeah. Good. Yeah. So let's see what's going to happen there. You already see that I had to work with the timeout options. I hope it will work now, especially when I run Zoom in parallel. Because what killed my example here was that it usually has a system timeout. After a certain time, it just refuses to continue sending something to the model if no answer is received fast enough. So this is something to play around with a little bit more of IT knowledge. Yeah, but we get something. The p-value. It's like being on trial for a statistics crime. Oh, this is new. You're trying to prove you're not guilty. Okay. That your phenomenon is due to chance by showing that, oh yeah, and now we ran out of this. Yeah, but yeah, so this is now also showing the timeout problem, but with only this running, a single sentence worked nicely. Yeah, and otherwise you really have to play around with this, but I limited it because my time here for presenting would just be overused otherwise. Yeah, but so you can have a lot of fun with these things, and you can do it as long as you want because no one will ever know about it, only your own machine. Good. Then I decided I give it a kind of task which I would usually ask of my students, and it usually doesn't work so well if I let my students do these kind of interpretation of the coefficients of a regression. And therefore I decided, okay, let's see what happens. So we create here live the regression model, and all I do is doing the summary of the regression model and just providing this summary as part of the user prompt. Here again, you see that I invested a little bit more into creating a nice system prompt. So telling it what it's actually supposed to do, how it's supposed to interpret these significances and the model fit and basically all these parts of the regression model, and then really give it the R output within the user prompt. And here this is happening what I was deleting before, that the two prompts are combined and then pasted as a long thing to the model. So here I used the GPT-4 model. This is the one where you actually start paying for this API usage, but doing it 100 times today cost me 29 cents. So it's still okay for playing around a little bit. And that's what I got. That's more than I ever got from students. So it starts out with the coefficients and doing this interpretation of the slope, even providing the units, which is something not always happening, but in this case, that was a nice answer. Then it's looking at the significances, the overall model fit, trying to interpret it because it has a high R squared. It suggests that it's doing well. Providing a summary for all this. Yeah. So it looks pretty good overall. That would be a lot more than we ever expect to receive at an exam. So if you write everything down at the exam, your teacher will know, or your professor will know immediately that you cheated with ChatGPT. Yeah, but basically it's able to interact, and that was the purpose here, to show how we can integrate parts of our R outputs into the input, the prompt input for these models. And this is happening in a very simple and easy way because we can directly include the summaries in here without much effort.
Copy and paste outside your website to like integrate everything.
Exactly. Everything happens directly in R. And also you receive the output in R, and I saved the output here, so I could even like integrate it automatically in the document which I'm producing, which is a really nice thing. So how to let your paper write yourself from now on. I will not be responsible for all these faked research papers. Good. And then I promised you that we will look into this sentiment analysis and this kind of classification with respect to sentiments. Since I was far too lazy to do this myself, I let GPT create these example texts and also the classifications, because it's already pre-trained more or less for this kind of sentiment stuff, and it knows what it does. But the purpose here is to show how you can use few-shot prompting, which is providing examples of something which you want the large language model to reproduce in a certain structure and in a certain way, based on how you provide the input and the output as examples, and then have it reproduce the very same thing.
Okay. So you could basically train it for your own language.
Exactly. Yes. That's what you can do. And if the tasks are small enough, you don't have to retrain a whole large language model. It's really just adapting it to learn certain very small, very predefined tasks and do them in exactly the way you want. Okay, so I also teach this to teachers for how to create the next Matura exams in the same style as the previous ones, or for the written exams, something which is similar enough to the already existing Matura stuff, and stuff like that. So this is very, very useful, and it's also very useful for research because we have very clearly defined questions, also very clearly defined structures, which we should keep to, and therefore it's an advantage if we can force the model to stay with our structure. And this is basically what it does here. So up until here, it's just a classical training, testing, splitting. Then we go into splitting up these text parts and provide these few shots here, which is that it learns the combination of the corresponding text and the corresponding sentiment, and in this sense learns this classification task. By when I give you a sentence, you tell me either positive or negative. And therefore it receives several of these for this few-shot prompting. Then has a system prompt in the background, which tells it, you are the sentiment analysis assistant. You will respond exactly with positive or negative. So this is where I'm limiting the classification task, that it only will have these two class labels and no other one. And then it receives the different examples, sends them, in this case again, to GPT-4, and allows me to do this labeling. I did that already once, and I don't want to overuse my API, or I have to overuse it. Okay, so we run it now. This could take a few seconds. We're finished. And with the two examples, I don't want to do too many examples because it will take long and it will be expensive, but it shows you the two sentences and how it did what it was supposed to do. So fantastic service and quality, it recognized as positive. And I returned to it after 2 days. Nothing worked as advertised. It recognized as negative. So in that case, it got everything right, which it got in all the 20 times or 50 times I've already run it today. And it randomly chooses which of these examples to use. Yep.
Two questions. So do you use the GPT-4 because the other is not good enough for this?
No, because the 3.5 has a limitation to how many tokens I'm allowed to send to it. And because it's for free. And in this case, because I sent the sentences with the structure of this is the answer for the sentiment, it gets too long. And then with the 3.5, it won't work anymore. So that's why I used the 4 for this example, because otherwise it couldn't have been done. Yeah.
The other question, do you think you could also train it to guess the gender if it gets names?
Possibly, if it receives enough data with names which are pre-labeled with respect to gender. So probably it has a lot already in its database. And it might know better than I can guess sometimes for names which are not from my cultural sphere, what gender they might refer to. But I didn't try it, but it might be something which is doable with this kind of methodology.
Actually, I have another question now. Do you know the university version of it's on GPT as well? Can you also connect it like that?
Only if the university version has a predefined account for creating these API keys. So usually you have to make some deposit, but if the university made a deposit there for the researchers to use, then you can use it. So it's the only relevant part is that you are able to create an API key, and as soon as you have that, everything's running fine. Good. Yeah, that was that. Then I only had a few more things. One was to write me a little bit more code now with a very unclear prompt, because write an R function that performs a t-test and returns the p-value is not a very clear task. If I give it to students, I will receive 100 different answers. Or maybe I received just one and the others just copied it from the best student. And in this case, I just wanted to let it run to see different outcomes here, because I already got basically a function which calls the t-test function and then does something like that. Perform the t-test by giving it the data and then calling the t-test function, because anything else would be stupid, and then returning the p-value of this test output. So it's in this sense smart enough to use what's already available in R and adapt to it. And I love, certainly, since you're a beginner, and since I'm obviously a dummy, it cannot need explain everything to me. This is something which happens only with GPT-4, that it provides all these extra blah blah things, like, oh yes, of course, and how can I help you along, and these things. GPT 3.5, we can actually try it because it's for free anyways. Will be much more concise with the answers. Like that. Here is an example. Performs the t-test and returns this. It does more or less the same function, but it's a lot shorter and a lot more concise. Whereas the other one provided a lot of extra explanations, which weren't really useful explanations. Yeah, since you're a beginner, I will do something easy for you. It's not in any way useful for my context. But these more modern models tend to add this human factor because they are closer to this training to beat the Turing test in being able to pretend being human. And if someone just throws you, here's an example, they don't appear very human and friendly. Whereas when they're, oh, of course, I will do this for you. Yes, since you are a beginner, I will explain it very, very briefly before we get into the thing. Then it feels more cuddling and nice and more human in a sense. And therefore, there is this trend, which I noticed now with trying it 100 times today with the different models, that if you want something very precise and short, then 3.5 is actually the better thing to use.
Not very well educated in that, but someone told me that GPT-4 uses that to, if you use the free version, so that your capacity is reached faster. Is that true? I'm just asking, could that be, or is it just the human factor?
I think the models are trained differently, and I also think that they have adapted system prompts. So because I have the paid version of these GPT-4 models anyway, so it wouldn't have to charge me extra for that stuff. And therefore I still notice that there is a difference in how it interacts in this pseudo-human manner and being cuddly and friendly and yeah, the American type of friendly. Yeah, but yeah.
At some point it feels like when you look up a recipe online and you have to read through like your full blog before you get to the recipe. This is more useful if you're actually working with it.
Exactly. Yeah. That's why I kept this example in here, because it's very nice to show the difference between the 4 and the 3.5 model, and that actually the simpler model might be more useful in certain use cases. And it's free. So win-win. Good. So the very last thing for today will be looking at Shiny, because I just wanted to know whether it works. And now this is the very, very simple Shiny app. And here we have these tokens. Okay, so it's limited to a maximum of 500 of them. So there will be very short answers anyway. So what kind of question do we want to ask? Let's see, maybe it works nicely. So how do we use LLMs in R? Sounds like a nice question. Let's see. Oh, yeah. That's actually a lot for my 319 tokens. So yeah, you install the required packages. These are not the ones we were using today. Oh, then you get Hugging Face. Then you can use the tokenizer yourself. Oh yeah, so you implemented it yourself in a certain manner. Yeah, and then it just stops in the middle of this because usually these prompts are meant for something longer, but here it really cuts off after the 319 tokens. So these are the total of the 319 output tokens. And then it ends in nothingness. There's no system prompt behind this thing, except for you are a helpful, knowledgeable scientific expert. I thought that would be nice. And therefore, because it's knowledgeable and scientific, it's immediately started providing R code. probably providing it with something else, like a helpful and friendly kindergarten teacher would give us a very different output for that kind of answer. Yeah. And here was the actual limitation for these tokens to use. Good. Yeah, so much for that. So I hope I could show you a little bit of insight into what's doable with R, what's kind of cool currently out there, how to apply certain things for different types of scenarios. And yeah, you can have the slides if you want. And now we also have a video, which should be nice and which I will stop now. Stop the screen sharing, but not the video.